Hi guys, a few days ago I did a video on reviewing the Intel B580 graphic card. I was interested to apply some AI tasks on that graphic card. In particular, I was trying to run a piece of large language model training code on that card, but I encountered some error that prevented me to see any results. Okay, I raised that issue in the PyTorch GitHub page. Yesterday, the person handling that issue asked me whether I can test something on my end to see any difference. So I did. Just to give you guys some heads up, I was able to run the code. I will go through that with you later, okay? And in addition, because I was able to run the code, I'm going to compare the Intel B580 and the 3090 card that I have, which is this one, okay? So I'm going to compare them with the LLM training task that I was trying to run last time, okay? I want to see the difference, okay? In addition to the GPU comparison, I will also put up a number of how long you will run for the CPU. In my case, it was the Intel 14700K. That's the introduction. If you haven't seen my previous video, please go to the description section and find the link. In that video, I briefly discussed how to set it up, okay? Okay, let's go. So this is the previous video that I mentioned earlier, okay? If you haven't seen that, please go there and have a look, okay? So here's the GitHub page. So yesterday, the person managing the issue asked me whether I can disable the integrated graphic card, okay? And I did try that. The way to do that is to go to Device Manager, okay? Or one way to go that. I think you can either use this way or you can disable it in the BIOS. So you go to the Device Manager and you open Display Adapters. So what you need to do is simply right-click the graphic card that you want to be disabled. So in this case, I want to disable the iGPU, which is the UHD. I just want to show you how to do it. I will say enable the device. Okay, it takes a while. Okay. Now you'll see it's enabled, okay? And what you can do, you say disable device, okay? Okay. Once it's disabled, okay, you can see the sign here. And you will also see in the Intel graphics software, if you go here, you can see that the iGPU is no longer in the list. Now they are only the B580 and my CPU. Okay. And then we go to, this is the Python code that I was trying to run. It is a replication of the ChatGPT 2. Basically, it tries to replicate all the bells and whistles of GPT-2. And in order to make it feasible on a desktop device, so what we did here is to train it with a smaller set of data, okay? So that it can be run on the CPU, on the GPU, doesn't matter, okay? And as you can see that, let's just run from the top, okay? So in here, I try to run it on the XPU. When I print the device, it says XPU. That means the XPU is available. And I want to know the specifics of the XPU. And it says B580. So it would definitely be the case because we disable the iGPU. There's only a B580 there, okay? That's active, okay? And then we can run everything, follow this, okay? We just say run all. So now it starts running. But you need to be aware of the results. Because we disable the iGPU, that means everything's run on the GPU, the discrete GPU, meaning the Windows, and also in this case, because I'm doing screen recording, and also the OBS, that means it will take down some of the performance. When OBS was on and I run this code, time lapse is 30 seconds. But when I turn it off and run the same code again, it's 17.5 seconds. So it's nearly half. Okay, that's quite good. Let me show you how long it would take to run the same code with CPU. Okay. Again, I will turn OBS off because that will be more accurate. Okay. So let's define device to be CPU. Okay, just double check it. Device. So it says CPU. That means we're using CPU to run the code. Okay, let me turn OBS off and run the code. Okay. As you can see, it will take quite a while. If you are going to work with PyTorch, like doing any of the deep learning training, I would recommend buying this card because the price is very competitive. It's only $250 US. You cannot get anything else in that price range that can do something like that. And you will save you quite a lot of time. Okay, it's finished. It's 1 minute 50 seconds. So it's okay. The CPU run just finished. As you can see, it took 1 minute 50 seconds for the Intel 14700K to finishing the running task. Okay, and it is roughly 6.3 times longer than running on the Intel B580 graphic card. Maybe let me explain a bit more about what this code does. As I mentioned, it replicates ChatGPT 2. Okay, it has all the bell and whistles. Okay, and as you can see, during the training, so we train with a small set of data, and then we try to test it along the way by giving a human readable prompts. Okay, then you can expect that once the model learns how to behave, it can spit words based on what you input. So in the beginning, your interest, every effort moves you, and all the predictions are commas. Okay, but as the model learns based on the data, and then you can spit out words like a human does. So now it's more, it is more sensible. So after episode 10, okay, so that means after going through the data 10 times, okay, and you can say that every effort moves you, then yes, quite insensible to the irony. It still doesn't make sense because we're trying to run a small set of data, okay, but at least it's much better than before. So that's how ChatGPT works. But in this case, we just try to run it with a very small data set just to demonstrate the points. Okay. Okay. Now you'll see how it performs with B580 and also the CPU. And what I'm going to do is to switch off and then replace this graphic card with 3090, and we can compare what will be the performance difference. Let's go. Let me just switch off and then replace the card. Okay, I remove the card. Okay. And now I install the 3090. Yeah, also to mention that it's a bit unfair fight with the 3090. It requires two 8-pin power connectors. So obviously this will be more performance. It requires twice of the power, or nearly twice the power. Okay. But anyway, we just, for comparison's sake, let's just do a comparison. Okay. Okay, just connecting everything and switch on. Let's try the 3090. The reason in the first instance I kept the iGPU on while testing the Intel B580 is because it has some advantage. If I use the iGPU and then I just test the graphic card, that means I can utilize the full graphical memory of the B580. But as they suggested me to disable the iGPU, that means that will affect how much stuff I can put on the B580 graphical memory. So that's a negative. So I hope Intel can address that enable people to run the iGPU and also the discrete GPU, and use the discrete GPU as an accelerator for their tasks. Okay, let's try to run another benchmark. Let's try to run the test on the 3090. Okay, let's do the testing for the 3090. In order to make it fair, so what I will do is, as you can see in the device manager, the Intel iGPU is disabled and the 3090 is running. So that means everything is running on the iGPU, all the Windows stuff. But it's a bit unfair because the B580 has only 12 gig of graphical memory, but this one have 24 gig. But anyhow, and also in this case, we want to compare nearly apple to apple. So I will try to run the test on Windows, because I know that if I run the same test on Linux, it might be a bit faster. But as I mentioned in my previous video, the Intel B580 has not yet get support from Linux. So we have to wait for that. Let's just run everything on Windows. So in that case, I will also need to install CUDA toolchain on Linux, okay, on Windows. So the way you do it is to go to PyTorch website, and you want to download 2.5, Windows, PIP, Python, and in my case it's CUDA 12.4. So let's need to mention that I already installed the latest driver for this graphic card, so I don't need to do that again. I just need to install the PIP packages required for running PyTorch. Okay. So I copy this line. Okay. Paste. So you will try to install all the required applications to run PyTorch for the Nvidia GPU. Okay. So in this case, because we will run on the Nvidia GPU, we will need because we will run on the Nvidia GPU, we need to enable CUDA. So I will comment out the following line. Okay. Okay. Okay, we get the Nvidia requirements installed. Let's try it. Okay. As you can see, it says CUDA. That means we're using the Nvidia GPU. And let's run everything to see how long it takes to finish the training task. Okay, here's the results. For the Nvidia graphic card, it takes 14.1 seconds. Hi guys, I realized I made a mistake while I tried to do the testing for 3090. It's because while I did the benchmark, I left the OBS running, so that will reduce the performance a bit. And I rerun the test again. I make sure that nothing was running. Okay, and the result is 13.2 seconds. So which is not too different from 14 seconds. So if you look at this spreadsheet, I present the results.
at the moment, I do not know the official price of 3090. The 1,000 Australian dollar price is from eBay, like eBay Australia. So I look at the recent transactions and look at the price they sold at. I only look at auction, so that means the last price will be the sell price. So obviously for 3090 there are lower end and higher ends, but I would say at minimum you will need to pay $1,000. So I put $1,000 there just for reference. And for the ARC B580, you can buy it in Australia at 469. And just if we just look at the price, the B580 is 53% less than 3090. But with 3090, you can only get it secondhand. And there are many downsides with buying a secondhand 3090. The first one is it can be very hard to get, even though we roughly know the secondhand price. But when you actually try to buy it, it can be hard. Secondly, they they might be used for crypto mining, so that means they could be very dirty. Their heat sinks can be rusty, and hence less performance, or even worse because of the way they were used. The heat can damage the graphic card board, so it's actually not an ideal situation to buy a used like a 3090 because you don't know how the author used that card. And lastly, I think 3090 has some thermal issue, so you also need to be aware of that. And let's look at the performance. If we just compare 3090 with B580, we use 3090 as the reference. So for that specific training task, 3090 finished in 13.2 seconds, and the B580 finished in 17.5 seconds. So the B580 is roughly 33% slower in this particular case. So I suspect that will hold true for other tasks, such as fine tuning. That's my suspect. I know that it's not. This test might not be rigorous, but I just want to show you how B580 performs in terms of large language model training. So just look at this result. I think it's quite good. So if we look at the performance and the price, so with B580, it's 53% less than 3090. Okay, remember that 3090 we use a second-hand price, which is much lower than price you can pay. The price you will pay at Amazon or a Newegg. Okay, while the performance in this particular instance it's only 33% slower. So I would say that's quite a good value. Furthermore, someone asking me whether 24 gigabyte model of the B580 is worth considering for machine learning workloads. And I did an estimate. So I assume that the 24 gigabyte model might be 50% more expensive than the current model. I don't know if that's the right assumption or not, but that's my guess. Because with the current model, a lot of the cost is due to the battle major chip. But I assume that if you add more memory, then you might introduce some thermal issue. You might need to they might need to change the thermal design a bit. But overall, I don't think the cost will increase by 50%, but I'm not sure. Okay, so I assume that the final price will be 50% higher than the current one for the 24 GB model. So if that's the case, and if we assume the performance is the same as the current one, okay, the compute performance, so you pay 30% less, and you get a product that's 33% slower than 3090. I assume that's still a good deal considering the risks of buying a used 3090. So I think that's a good option to buy B580 24 GB model. And in fact, that's my plan too. I'm thinking once that model is available, I'm going to buy that one. I haven't told you guys in the previous video recording. I actually sold my 4090. I sold that 4090 because I don't think I would need to use it a lot, considering I already have 3090, and I used some of the money to buy the B580, and I was thinking once the 24 GB model is available, then I will give the current one to my wife for video editing, and then I will use the B580, the 24 GB model for LLM related stuffs, and I will use that in conjunction with my 3090s. So that's my plan. I hope this follow-up review will give you more color about B580, and overall I think that's a very good model to consider to buy for machine learning workloads. And that's about it. Oh, I want to mention that I might do a video on how to build a budget, like a low-cost workstation for machine learning using this B580 card. And if you are interested, please consider subscribing my channel, and hence you will get informed once that video is available. And that's about it. Thanks guys for watching. See you. Bye.